One more thing in conclusion of this 32-bit difference implementation, let's also check for conditions such as this arithmetic overflow. So remember, in our documentation for double word to ASCII conversion, we mentioned that the acceptable decimal range for word length or double word length of 2's complement number is this range. So for example, if I start this program again, Control F5, and if I try to enter a number close to this big number right here, so it's like 2 0 0 0 0 0 0 0 0 0, something like that, and then subtract a negative number which is also like this. All right, so 2 billion minus 2 billion, so that should result in adding 2 billion plus 2 billion, because we're going to take this positive number and subtract a negative number, which will of course reverse the sign, and so this will be, the subtraction will actually do addition. So let's try this, and there we go. We have this arithmetic overflow reported by our program as a result of this subtraction, and that's just a nice way to report an arithmetic overflow, because the result of this could not be accommodated in our difference. I also decided that if I want to test this program multiple times, you see that instead of exiting here, what I do, I actually jumping all the way to the top of our program. So just for the sake of testing, if we want to be able to test multiple times, we can jump back to this label, and you see that I just added this unconditional jump at the end of the program. So let's try some values like, I don't know, 200 or 2000 minus 1000, and the result is 1000. So this works, and so instead of exiting, it just wraps around and jumps back to the prompt for the first integer again. So I'm just jumping to the top of our main procedure by adding a jump to this label at the bottom of our program. So this return command is no longer reachable because we're unconditionally jumping here. But I'm just doing it for debugging purposes so that I can enter multiple values over here. So this is pretty much the conclusion of this lab. So we were able to, I'm just going to close this run, and so we were able to hopefully satisfy these two computations and check for bad input formats, and also take a look at the sum and difference. All right. So when you submit the results of this lab, you can, just like I did, you can split this into two files and submit two files for the results of this lab. Okay, so it's acceptable to do it like I did, because first I solved it for 8-bit, and then we made a copy of the file, and now there is a solution for the 32-bit. Also, with respect to comments, let's take a look at what we have here. So I think there is a reasonable amount of comments, and the macros such as output and input don't really need a lot of commenting, because it's obvious that we're trying to display user prompt or display information to the user. So really this should be coming from descriptive name of the label that corresponds to the line of characters that we're trying to print, and we can keep these labels themselves quite readable, so that we don't need to add additional comments for those. The rest of the code hopefully has enough comments, but the comments can always be improved, and in general, assembly programs often look like a line of commands or macros that we use for our input-output. Then parameters, you see I'm trying to align everything to make it as readable as possible, and normally all of this is accommodated by a set of comments, which is like a pseudocode or descriptive comments, or a mixture of both. And that is the more or less appropriate style for assembly programs.